example, and basically I'm getting progressively more and more stuff that you have to do on your own when you set it up. So the first one was they gave you almost everything, you just had to find profit. The second one, they gave you the demand and cost, so you had to find revenue, then profit. This one, you have to find everything. You have to sort of set it up from scratch for the revenue part, all right, or to optimize revenue. And there's one like this, I believe, in your math lab example. So I've got Jackson University's determined the price to charge, wants to determine the price to charge for tickets to a football game. They have found that the price set, if the price is set at $26 per ticket, attendance averages around 20,000 people per game. Every decrease of $5, right, when they drop the price, more people should be willing to attend. So for every $5 drop in the ticket price, 4,000 more people will attend the game. What price per ticket should be charged to maximize the sales, right? Revenue is your sales. All right, revenue the generated by ticket sales. What is the maximum revenue and how many people will be in attendance on average? Now, it didn't tell me the size of the stadium, so what my domain is, but I am going to figure that out based on price. All right, what the maximum size of the stadium is, so I don't go in the negatives. Verify that your answer does yield a minimum. All right, so this one requires me to completely set it up from scratch. So the first thing I want to do, well, I want to find revenue. All right, revenue is price times quantity. However, price is a changing, right? I want to find the right price, right? This is the current price, but I don't want to keep it at the current price. I want to find the right price to meet the demand that will optimize my sales. And so before I can set up my revenue, I have to find that price demand. And the book does do this in a slightly, like I said, a lot of times I will do it in a different way than the book, so you have two ways to set something up. All right, so I'm going to do mine slightly different than what the book does. All right, find the price demand. Well, the price demand is the linear price demand price. All right, P is going to be my price for the ticket in dollars. X is going to be the number of people in attendance. All right, so price is slope times X plus B. Price times number of people in attendance. All right, so first of all, they did give me a point. They gave me a starting point where they're currently at. The starting point is when they set their price, 26, 20 people on average. So again, we're going to use averages, but 20,000 people will be in attendance. All right, so X is the 20,000. Price is the Y part, which is 26. All right, so that's the starting point. That comes from their current selling price is $26. When they sell it at that price, 20,000 people will be in attendance on average. All right, then I find my slope. Well, slope is the change in Y. Well, Y is the change in P, which is price, over the change in X, which is number of people in attendance, right? Which the problem actually gives me that change. That's what this line is that I'm going to highlight at. When they lower price by $5, 40,000, again, based on averages, 40,000 more people will attend the game. And so those are changes, right? Decrease. So we're going to go down by 5, -5. More people will be in attendance. Well, the more people being in attendance is the 4,000. And so those are these numbers. The change in price is if I lower it by $5, so it's a -5. 4,000 more people will be in attendance. That will be the change in the number of people. All right, so there's my slope. So if I reduce that, it reduces to -1/800. All right, so there's my slope. There's my point. I can find my my linear price demand equation by plugging my numbers in. All right, 26 goes in for price. Slope I just found. X was 20,000, and I need my y-intercept. All right, so first thing, multiply out that -180. -1/800 times 20,000, which does come out to a nice number. Comes out to -25. Add the 25 to the other side. And so my y-intercept in this case is 51. All right. So my price demand is my price equals -1/800 times X plus 51. Right? That's the price demand that goes with the price per ticket and the demand for the tickets. All right, step 1, find that. Step 2, so that's actually really the hardest step. Now the revenue is just take that linear price and multiply it by another x. All right, revenue is that price demand times x, so revenue is my negative 1 over 8. I had to write that wrong. 800x plus 51 times another x. So you've got to remember times another x. And so my revenue is negative 1 over 800 x squared plus 51 times x. There is my revenue. Alright, so setup. There's the setup. So there's first part, set it up. And once I've got it set up, well then this is just optimizing like we did in the last examples. Alright, find my optimum value, and so on. Now, before I get started with the optimum value, I am going to find my correct domain, right? Because again, in order to verify it, I have to have my domain. Now, first of all, X represents people going to a game, so at the very least, the domain should be positive. But I'm actually going to set it up because price should also be positive. And so that linear price-demand equation needs to be positive, so I need to solve that. Negative 1 over 800 x plus 51 has to come out positive as well. Alright, multiply by and again I'm multiplying by negative, so I'll have to remember to flip my sign. And so I get x less than or equal to whatever 51 times 8. So it comes out to be 40,800. Alright, so the domain, which again I'm assuming the size of my stadium will match this, is I can have 0 people at the football game up to a maximum of 40,800. Alright, otherwise my prices go negative. Alright, so that's my precise domain for my revenue, which was negative 1 over 800 x to the second plus 51x. Alright, now I'm ready to optimize. Alright, so I find my critical values. That's smaller so I can see everything. Find the criticals on my domain, which means find my derivative and set it equal to 0. Alright, so I get negative 2, so negative 1 over 400 x plus 51, set that equal to 0. And then key step, make sure you always show that. Move my 51 to the other side, and then multiply by negative 400. So x is equal to whatever 400 times 51 is. 20,400. Right, that's the optimum value. Basically, you want the stadium at half capacity, right? Because it's cheaper, and that'll optimize your sales. All right, so now the verify. So since there's only one critical value, I can still verify using the second derivative, so I am. You could use the closed interval case where you found the revenue at 0, revenue at 20,400, revenue at 40,800, but I would also accept the second derivative test because there is only one turning point. But I'm going to test this way. Alright, so I'm plugging all of these values into my original revenue equation. At least that's kind of in my way where I have it drawn here. So 0 comes out 0, right? 0 comes out nothing. When I plug 20,400 in, it comes out 520200. And when I plug 40,000 into my revenue equation, 40,800. I believe it comes out a negative number. I'm going to double check. Yeah, it comes out a really big negative number. This comes out negative 160,727. Alright, so since it's negative, this is my optimum value, and that is my max. Alright, so the maximum revenue is 520,200 when 20,400 tickets are sold. I want to make sure I answered all of the questions. Nope, I haven't found the price per ticket yet. Alright. Found maximum revenue, how many people, I did verify. Alright, so the last step is, well, what's the price? What's going to make the magic happen? So I need this price demand equation, and I have to plug in my 20,000 into it. 20,400. Alright, so now, and the price needs to be they've almost actually got their perfect price. $25.50. $25.50 per ticket. Alright. So that one was a tougher one. That one when you kind of had to set it all up. All the information was there, but you had to find all the parts. You had to find the linear price demand. You had to find revenue. You had to optimize, determine the domain, and then verify with all the steps. Alright, we will stop there. The next set of notes goes with a very special type of problem called the inventory cost. And if you want to know more details about it, again, I encourage you to watch the MyLab videos first about inventory costs. Because, again, I'm not going to go over what they exactly are. I'm just going to solve additional applications. If you want to know about them, watch the videos on MyLab.